Hello guys, my name is Engineer Ali. We want to look at astronomical telescope and what do we understand by astronomical telescope. Astronomical telescope is an optical instrument that uses lenses or mirrors to collect and focus light from a distant celestial objects, making those objects brighter and magnified for observations. That is to say, astronomical telescope are optical instrument that uses lenses or mirrors to collect and focus light from a distant celestial objects and produce a larger, brighter, and magnified image for observation. So that is to say, an astronomical telescope are optical instrument that uses lenses or mirrors. When I say lenses or mirrors, I know many of you are confused about how can an astronomical telescope use a mirror. We have what they call a reflecting telescope. A reflecting telescope is a kind or a type of astronomical telescope, which I'll be looking again in the next class, or be looking at them in the next series of this class. But what are we using this instrument to collect and focus light from a distant celestial object and produce a larger why did it do that? To produce, let me put that word, to produce a larger, brighter and magnified image for easy observations. So now, what are the distance objects that we are talking about? That means to distance objects like the sun, the stars, the moon is what we call the celestial object. Because when I mention celestial object, we are giving e.g. example of a celestial object are the sun, the stars, the moon, and etc. So celestial objects are are stars, the moon, and the sun, and so forth and so on. But let us see how an astronomical telescope is built. Now, number one thing that brought about astronomical telescope is because of the defect created by a compound microscope. Don't forget, a compound microscope uses two lenses, just like an astronomical telescope. But an astronomical telescope produces what they call an angular magnification. Although compound microscope produce what we call the linear magnification. I will tell you the reason why we call it an angular magnification as the classes progresses. Now, when we talk about an optical instrument, meaning that there are some things you should notice here. That means I said uses lenses. They have not mentioned any how many number of what lens that is used. Is it one? Is it two? Or it uses the same number of lenses in what compared to that of compound microscope. We have how many lenses now used in what in compound microscope? We have two. What about in astronomical telescope? We also have two. So that means the two of them have what similar things in terms of the way the number of lenses used. Then another thing again is that the two of them produce the final image is virtual, inverted, and magnified, which is also what the same as what the astronomical telescope also produce virtual, inverted, and magnified, just like compound microscope. But an astronomical telescope produce a better magnification. It can view distant object or distant celestial object. While what microscope can view close object, close object. Now, there is a shortcut I will give to you here. We call it Toles. Repeat after me, Toles. What does that mean? It means that the telescope is a T there. It means in astronomical telescope, in this astronomical telescope, the telescope, the objective length is longer, then the eyepiece length is shorter. And in what? In telescope, objective length is longer, then the eyepiece length is what? Shorter. So have it in mind. So let us draw it. That is to say, what we have just mentioned now, that in telescope, objective length, longer focal length, eyepiece length, shorter focal length. That means objective length has what? A higher focal length than the eyepiece length. That in a compound microscope, the two of them are shorter. And even if they are short like that, the eyepiece length is what higher than objective length, because that eyepiece is the one acting as what the magnifying glass. So it's the lenses that acting as what the lens that act as a magnifying glass is what we call the eyepiece lens. We have two lenses. One is we're going to pick the object. The one is to cast the image of the objective lens and use it to produce a kind of a magnifying glass to magnify the image. So as such, we say what the eyepiece lens in a compound microscope is called a magnifying glass. So it has a higher focal length than the objective length. Go and watch the video. Although the two of them are short, but in this case now, the objective lens is one collecting the light, is the one that will pick the image from that distance. So it's having a higher focal length than the eyepiece lens. Let's do a rough sketch of what. Now this is what, let's call this one objective lens. Let me locate the center. Now let's draw our eyepiece lens here. So this is eyepiece lens. Now this eyepiece lens E. Now let's take an image from infinity. Let an image come from infinity, from a distant object. Now the image is coming from what? The object is coming from distant object. To cast the image here, and where the image is from here now is what? Between the eyepiece lens, eyepiece focal length and the pole. Meaning that what? Look at it. This is now the objective lens now. So this is the objective lens. The objective focal length. That is where the image that is coming from, maybe the stars, is coming to meet to form its image at the focal point or the principal focus of the objective lens. Now, if you extend it now you have what? Now let's call this one beta. So the image is for form here like this. This is the image. Now, if this is the image, this is a rough sketch. Now, then this is what we call the angle suspended by the what? The stars, the distance object. And it's equal to this angle here. This angle. Now, this angle suspended by the eyepiece. So the eye will be somewhere here to view the image. So this was the image formed by the objective lens. The image formed by the what? The objective lens is what? Real, inverted, and what? And diminished. So it is what? Real, inverted, and what? Diminished. So this is the what? The image formed by what? By the objective lens. Now what about the image formed, the final image? The final image formed by an astronomical what? Telescope is, or what? Just what? Let me say is what? Virtual, number one. Inverted, number two, point here. And magnified. And magnified. So that is what in short form we can say V. Inverted. If you check the image now, look at it, it is magnified. Check, compare, and don't forget that the final image is what? And it is closer to the what? The objective lens. Is closer to the objective lens. Don't forget. Now look at the image. It's not closer to, look at the objective lens. Look at the final image. This is what we call, this is final image. And the final image make an angle of what? Beta, which is measured in radian. Then this one now, the sun or the distant object or the stars make an angle of alpha with the objective lens. So in this case now, what we should know is that underline this particular, for example purpose, it is the final image is virtual, inverted, and magnified. Then the image formed by the objective lens, that means the image of the star formed by the objective is real, inverted, and what? Diminished. Then don't also forget that the image suspended at the what? That means the angle suspended at the what? At the eyepiece lens can be calculated. Now don't forget, this is what we call a simple what? Astronomical what? Telescope. A simple astronomical what? Telescope. If you have the compound one, the compound one will not be like this. I will tell you how the compound one, the normal one will be like. That means astronomical telescope at normal adjustment. What will it result to in the diagram? What will be the diagram? How will the diagram look like? So now, Let us see the diagram of what? Of astronomical telescope. How will it look like? Now look at the diagram here. I'll be fast with it. This diagram. Now, I haven't drawn to this point now, they'll meet here. Then now this is what? Abnormal adjustment. This is what? Astronomical telescope. Telescope at what? Normal what? Adjustment. Now, what is the difference between this and this? Now, let me show you something here. Now, the distance from here to this place is f naught. Although it's longer than what? This one is fe. Even at normal adjustment, f naught is still what? Greater than fe. So, in that case now, the distance of separation between the lenses is L equal to what? F naught plus Fe. F naught plus Fe. Now, this is the T I was talking about the earlier. Now, look at the board. The image, the final image is what? Is still what? Virtual, inverted, and magnified. But is now sent to what? To infinity. Why? Because the F naught and Fe coincide. That means the focal length, the objective focal length and the eyepiece focal length meet. They coincide. The objective focal length and the eyepiece focal length is what? Objective focal length and the what? The eyepiece what? Focal length coincide. Coincide means meet. So that means the distance, the color, the light collected by the what? Objective focal length from a distant object now focused what? And produce an image at the what? The point where the what? The that means it produces an image at the eyepiece focal length, which is also the point at which what? Objective focal length and eyepiece focal length are what? Are meeting. So that means at this point, objective focal length is that point, eyepiece focal length is also at this point, let's say point N. So in this case now, they will not send the image because it's now formed like this one now. The image is formed, you know, between the eyepiece focal length and the optical center of the eyepiece lens. But now, in this case now, the image of the distant object is formed at the eyepiece focal length, which is also the point of the what? The objective focal length. So that means that this point is what? The point of objective focal length and the point for eyepiece what? Focal length. That's why you see some textbooks or some what do you call it, journal, they will write it like this. Look at it. They will put the F naught and F what E at that particular point. So from here to this place is what we call the L. From here to this place is what we call the length of separation of the what? Of the lenses. So in this case now, we have been able to what? Establish the what? That the length of what, or the distance of separation between the what? The lens is equal to F naught, the focal length of the eyepiece, plus the focal length of the objective lens. And don't forget that a simple what? Microscope is different from, or compound microscope is different from astronomical telescope. Now a simple astronomical telescope and a normal adjustment is that the image here is virtual erect and magnified, but not at infinity. But here the image is at what? Infinity. And in this case now, the eye in this case will be relaxed. The eye here placed to see this image will be what? The relaxed. So the eye is what? Relaxed. When the what? The image is what? Formed at what? At infinity. So in this case, the eye is relaxed there. Now, but what is the angular magnification of this particular one? Astronomical telescope? What is the what? The angular magnification. Now, don't forget magnification, angular magnification is equals to what? Tan beta over tan alpha. Angular magnification is equal to tan beta over tan alpha. That is what we call angular magnification of a what? An astronomical telescope. But we notice now that, okay, from here, let me use this one as what the basis of the analysis now. Now, if you check here now, this angle here, so tan beta is what? Tan beta is what? Opposite, let's call this one D, the height of the image. Let's call it D. So from here to this place, if you check the diagram clearly, you see something like this. Where here is beta, here is D, and here is FE. So if I want to use SOHCAHTOA, tan beta is equals to what? Opposite over what? Adjacent. So that is that. Opposite over adjacent. Now if you want to now find tan alpha is the angle suspended by the objective lens. So what do we do now? Look at the diagram again here. This is the diagram. Then from here to this place is what we'll say. If you check the diagram, you see something like this. Something like this. Then this one is alpha. Here from this point, the optical center of the eyepiece of the objective lens to the image, which is also D, is equal to what? F naught. So in that case now, tan alpha is equal to also what? Opposite over what? Adjacent. So that means D over F naught. Now if you now put it there, we want to have it as what? D over Fe divided by D over F naught. Therefore, angular magnification will now give us what? D over Fe times F naught over D. So this D will cancel out this. So what we are going to have is what? F naught over Fe. So please take note of that. So the angular magnification now is equals to what? F naught over what? Fe. Another thing again you can say, because this angle now, tan alpha note is approximately what? Alpha. Why? Because this angle is a small angle, so it will approximately alpha. Similarly, tan beta is approximately beta. So we can write this equation as what? Beta over alpha. So this one can also be the what? The formula for what? For angular magnification of a what? An astronomical telescope. The angular what? Magnification of an astronomical telescope. So please take note of that. And don't forget the final image formed by an astronomical telescope. We have also spoke about the distance or the length between the lenses when at normal adjustment. So I believe that you enjoy the class. It's just that you have to go through it over and over again and see what you want to questions that you want to ask that you can send to the comment section when after watching the class, after watching the video about this astronomical telescope. I want to appreciate you for watching, and those of you that are returning viewers, thank you. God bless you. Those of you that are just meeting my video for the first time, I am Engineer Holiday once again. Thank you. God bless you for watching, and please subscribe to always get more of our video. Thank you.